Hello, Jude. Good morning.
Good morning.
Good
Good
morning.
morning, Jude.
Hi, Ella.
I haven't heard you say good morning to me, Jude.
Good morning, Mom. Cam.
Good morning, Jude. How are you?
Okay. What about
Good.
you?
Yeah, I'm good too. I just ate my breakfast late, but I'm ready for our session. How about you?
Yes, I'm ready.
Oh, that's good.
We have J2 Pro here, who is the owner of Galaxy J2 Pro.
Hi, sir. Good morning.
Okay, si Miss Hannah. So, Ma'am Jem, I think the group is already here, complete. The group is already complete, so I think you can already start. I just
Yes.
finished uploading the mathematics, the multiplying rather.
Okay, sure.
Ma'am, that was monomial to binomial and polynomials. Meron bang ano ma'am, binomial to binomial, trinomial to
That
trinomial?
will be. Yes, that will be our lesson for today, continuation about multiplying
Ah,
polynomials.
so I think that's a more complicated topic.
We'll be using the prior knowledge in multiplying a polynomial by a monomial and just expecting to have more terms involved, but we'll still be using the distributive property.
Okay. Just for clarification, this is not to scare the students.
Yes.
So ma'am, you now have the floor. I will allow you to share your screen.
Okay, good morning, everyone. So it's Friday. Happy Friday.
Happy Friday, ma'am.
Happy Friday,
Yes.
ma'am.
Happy
Okay.
Friday.
Yes, thank you for the complete responses. So we just had a question left and answered yesterday about the highest mountain. Though, Jude, can you still remember your answer?
Yes,
What is it?
Mount Everest.
Yes, you got it right. And why is it that even Mount Everest was even not discovered yet, it was still the highest mountain in the world?
Well, just because it haven't been discovered yet, it didn't change its size.
Very good. Yeah, an amazing answer, Jude. It is just like Mount Everest is the highest in the world, the highest mountain in the world, even if it was not discovered yet. It was already there, right? Yay! Maybe we can have a round of applause for Jude. Yay! Okay. Again, it is trying to think outside of the box for these brain teasers before we start our lesson. Okay. Maybe I can give you one more. It's either you like it or like it. I'll be giving you one more question, and it's this: what letter comes next in the following sequence? Again, what letter comes next in the following sequence? D, R, M, F, S, L, T. Okay, you may share your answer. I'll be giving you a clue. These are letters associated to music. D, R, M, F, S, L, T. What is the next letter? An idea?
D, ma'am.
D, yes, Ella. And how come it's the letter D?
D, ma'am. In music, it's do.
Oh, very good. Yay, good job. These letters are letters that represent one note in the diatonic musical scale. So we have do, re, mi, fa, sol, la, ti, do, so, D. Yeah, it's a D. Okay, thank you, Ella. Another one. Maybe this. A boy is walking down the road with a doctor. While the boy is the doctor's son, the doctor is not the boy's father. Then who is the doctor? Hey, think outside of the box. You can share your answer. Should I leave that question instead? And then you can have the whole day to think about the answer. Okay. Now let us start with a review. I think we're ready to just have a short review and then start with a continuation of our lesson. So yesterday we did multiplication of a polynomial by a monomial. And let us have this 2. A parenthesis a plus 5 is equal to, maybe we can have Jude for this. Jude, can you share us your answer for this? A parenthesis a plus 5.
Well, that it is the a squared plus 5a.
Very good. That's good. Thank you. Let's have the second one for Ella and Hannah. Negative 7 multiplied by n squared minus 3n plus 1. Girls, negative 7 multiplied by n squared minus 3n plus 1.
Negative 7n squared plus 21n minus 7.
Minus 7. Yes. Okay, that's correct. Was that from Hannah? I think.
Yes, ma'am.
Yes. Okay. Negative 7n squared plus 21n 21n minus 7. Thank you. So I guess you're ready for the next. Today we will be having our lesson about multiplying polynomial with a polynomial. Okay. First, again, yesterday we had multiplying polynomial by a monomial. But this time we will be having multiplying multiplying a polynomial by another polynomial. Okay, and we can start with this example first for better understanding. 24 times 36. Usually, for us to be able to understand more challenging questions, we start with the basic knowledge why or how it works, because when we understand the basic ones, it will be easier for us to understand the more challenging questions as well. Now, let me start our lesson with multiplying whole numbers. 24 times 36. Can you tell me the steps in doing this? Yes, anyone can share. How will you multiply 24 and 36? What do you
Ma'am,
do first? Yes?
20 times 30,
20 times 30. Okay, good. And then
6 times 4,
6 times 4. Okay, and then
and then,
some more.
and the other answers, ma'am.
Okay, so you will have 20 times 30, which is 600. And then 4 times 6, which is 24.
Yes, ma'am.
Okay, so what would you do next? Are you going to add these two answers? Or you still have
Yes.
another? Oh, okay. So if you're going to do that, you will have 600 plus 24, which is equal to 624. Now, may I ask Hannah, oh, sorry, who gave answer? Was that Ella or Hannah?
Ako, ma'am.
Ella, right?
Yes, ma'am.
Yes. Okay. Sorry, because I cannot see in my screen anymore who's talking since I have shared the screen and minimize other stuffs. Okay, it's okay, Elle. Thank you. So maybe we can have it from Hannah. Han, do you do the same steps? Or if not, then can you share us your final answer? 24 times 36.
24 times 36. Yung normal lang na steps, ma'am.
Yes? Yeah. Can you share us your steps and then your answer?
6 times 12. Then 6 times 4 equals 24. So 144. And 3 times 2 equals 6. 600 to 640. 744. 2 times 4 equals 8. The answer, ma'am, is 824.
I guess you missed something. But I understand your process. You actually multiplied 24 times 6, right? Then just
Yes.
individually multiplied 2 by 6 and then 4 by 6. And then followed by 24 times 3. And then 2 times 3 and 4 times 3. Am I right?
Yes, ma'am.
And then you added the answers. Supposedly we have 144, that was right, plus 24 times 3 is 720,
700.
which gives us 800,
864, ma'am.
yes, 864. So, okay, thank you girls for sharing the steps in multiplying whole numbers. Now, I have the same common steps that you did, where you actually multiplied digits, okay, where you also use distributive property. However, with Ella's case, she just missed 2 more steps or 2 more numbers to multiply. And for Hannah, yes, miscounting at the last part. But again, I get what you mean and how you do the steps. Now, 24 times 36 is equal to 864. Now, I have here a few questions that will help us again check our understanding and clarify the relationship between multiplying whole numbers and multiplying a polynomial by another polynomial. First, explain how the distributive property was used in the first step of 24 times 36. So again, as what Hannah did, and the same with Ella, though there was just missing steps, the number 6 in 36 was multiplied by 20 and 4, or 24 times 6 and then 24 times 3. Actually, that's supposed to be 24 times 30, since in 36, 3 has the value 30. Okay? Or you can also say that 3 is on the tens place and the value is 30. So 24 times 30, which is 720. Okay? Another. Distributive property was used in the second step when you already multiplied each digit. So 24 times 4 times 3, 2 times 3, and then 4 times 6 and 2 times 6. And on the third steps, having your product for 24 times 6, which is 144, and 24 times 30, which is 720, you combined, okay, you combined 144 and 720, first the ones, then the tens, and finally the hundreds, which gives us 864. Now, to show the relationship, again, when we multiply a polynomial by a polynomial, we do the same steps as we do in multiplying whole numbers. Okay? Now, let us have an example for better understanding. Find the product of x plus 3 and x plus 2. So basically, we are starting this multiplication of polynomials with a binomial with another binomial. So first, we distribute x plus 3, the terms x and 3, to both terms of the other factor x plus 2. So you can have first the first term, x plus 3, as the first term x. So x times x plus, okay, distribute x to the 2. So x times 2. And then the second term in the first binomial is 3. So 3 distribute to x again, plus 3 distribute to the other term 2 of the second binomial. Then multiply x times x, we have x squared. Then x times 2 is 2x. Then 3 times x is 3x. And then 3 times 2 is 6. And then what's next is to combine the like terms. Jude, can you identify like terms in our polynomial? X squared plus 2x plus 3x plus 6, please.
2x plus 3x plus
Yes. So 2x and 3x are like terms. And how much is it when we combine 2x and 3x, Jude?
5x.
Yes, you got it right. So then, since we have x squared with no other terms with x squared, then we just copy x squared. And then the 2x plus 3x, which Jude said it's 5x, which is correct. And then copy the constant 6. Therefore, x plus 3 times x plus 2 is equal to x squared plus 5x plus 6. Okay? Let's have another example. Y plus 8 multiplied to y minus 4. Again, y plus 8 multiplied to y minus 4. So in our first binomial, y plus 8, we can distribute y to y minus 4, which gives us y times y squared, y times negative 4y. And then from our first binomial, after distributing y to y minus 4, we will distribute positive 8 to y minus 4. So 8 times y, 8y, then 8 times negative 4 is negative 32. We have answer from Ella. Elle, can you combine like terms and simplify? We have now y squared minus 4y plus 8y minus 32.
Y squared, ma'am.
Okay, copy y squared.
Then 4y.
Yes, positive 4y. And then
Minus 32.
you got it right. Very good. So that's it. Y squared plus 4y minus 32. Maybe we can have the last example for the binomial with another binomial. And then we will proceed to more terms, polynomial with another polynomial. Maybe a trinomial, okay? Number 3. Let us have 5x minus 4 multiplied by 2x plus 8. Again, 5x minus 4 times 2x plus 8. Han, can you help us with this? Maybe you can do 5x times 2x plus 8.
Yes, ma'am. 5x times 2x equals 10x squared.
Yes.
Then 5x times is the given again.
Yeah. We have the second binomial 2x plus 8.
5x times 8
Yes.
equals negative 40x.
Yes, you got it right. Thank you, Han. This time, let us have from Hannah. Han, can you distribute negative 4, the second term of our first binomial, to the second binomial 2x plus 8? So negative 4 times 2x plus 8.
Negative 8x minus 32.
Okay, minus 8x minus 32. Very good. Jude, I need your help for simplifying. Final answer, please.
Yeah, 10 squared plus 10x squared plus 32x minus 32.
Wow, good job. Yes, 10x squared plus 32x minus 32. So again, we just need to use prior knowledge on the prerequisite lessons. We have the rules for integers, combining expressions, and distributive property. Okay, thank you, girls and Jude. So far, I think you now understand how to multiply a binomial with another binomial. Now, let us challenge ourselves with more terms involved. I am referring to a polynomial multiplied by another polynomial. Okay, polynomial with another polynomial. And let's have it. Oh, I'm sorry. Before that, I want to mention about another method aside from distributive property. We also have the so-called the FOIL method. Let me introduce here FOIL method. Does anyone has idea? What do you mean when you say we use FOIL method? Any idea about FOIL method?
FOIL method, ma'am, is first,
Inner
outer,
last.
inner, last.
Wow, good. First we have the F, and then the O, the outer, and then the I is for inner, and L is for the last. Yay! That's it. So let's just have one example, or using our first example, x plus 3x plus 2. Let us use the FOIL method. First, x, the first term in the first binomial is x. Then the first term in the second binomial, x plus 2, is also x. So x plus x is also x squared. Let me just show here for others who needs to master this or review. We have the so-called FOIL method, another way of multiplying binomial with another binomial. So f is for first. If we have x plus 3 multiplied by x plus 2, the first terms of both binomials are x. So x times x. And then FOIL O is outer. Outer, we have the x and the 2. So x times 2. And then I, inner. If you're going to write x plus 3 and x plus 2, the 3 and the x are the inner terms. So we have 3 times x. And then our x plus 3 and x plus 2 has the last terms 3 and 2. So 3 times 2. And then we get the products. X times x is x squared. And then x times 2 is 2x. 3 times x is 3x. And 3 times 2 is 6. So we will go to the same steps as how we did it in the previous example, combining like terms. So we will have x squared. We just copy that. And then 2x plus 3x is still 5x. And then copy the constant 6. So if you're going to recall our answer from example number 1, x plus 3 times x plus 2, using distributive property, is x squared plus 5x plus 6, which is definitely the same when we use the FOIL method, giving us the answer x squared plus 5x plus 6. So either ways, either methods will do as long as we have the same answer. And if specifically stated in the instruction of your teacher's assessment. Okay? I need to ask you three if we need another example, you think, for the FOIL method, or we'll just skip and then you'll just practice by yourself later. Maybe one for me to know if you really can consider this method as well. Let us have example number 5. Now, using FOIL method, z minus 6 times z minus 12. How about that? Again, z minus 6 times z minus 12. Can you give us the first terms first? Anyone can just share. Again, our binomials are z minus 6 and z minus 12. FOIL, F first. Can you mention the first terms?
Z and Z, ma'am.
Yes, so we'll have z times z is equal to
Z squared.
z squared. And then let us have O, the outer, z minus 6, z minus 12.
Z minus 12.
Yes, z and then negative 12, which is equal to,
Negative 12Z.
yes, negative 12z. So let me write instead negative 12z. And then our inner,
Negative 6Z.
negative 6, and then z, which is negative 6z. And then our last terms.
Plus 72.
Yes, very good, Jude. So we have negative 6 and negative 12 will give us positive 72. Now, can you combine the terms? You can combine and copy those terms with no like terms. Final answer, please.
Z squared minus 18z plus 72.
Okay, good job. Yay. That's it. So again, you can use either distributive property or the FOIL method to multiply a binomial by another binomial. So I guess we're ready for more. Let us have a polynomial with another polynomial. We have now example number 6. And here we go. 4x plus 9 times 2x squared minus 5x plus 3. So since we're having here a binomial multiplied to a trinomial, okay, a polynomial with 3 terms, we cannot use anymore the FOIL method, but instead the distributive property. Okay, so we will distribute 4x plus 9, okay, 4x first to 2x squared minus 5x plus 3, followed by the second term of our binomial, which is 9, to each of the terms of our trinomial 2x squared minus 5x plus 3. Jude, can you distribute 4x to 2x squared minus 5x plus 3, please? Give us the product. First,
Add up the 8x squared cube.
yes, cube.
Minus 20x squared plus 12x plus the cube plus 18x squared minus 45 97.
Oh, okay. So Jude continually distribute 4x to our trinomial and then our 9 to our trinomial. Okay, let's have it this way. 8x cubed so far minus 20x squared plus 12x. Okay, and then with the 9, we have 18x squared, correct? 5x plus 27. Jude, can you please check if I have written all the answers you have given us?
Yes,
Yes,
okay.
okay. Thank you. And then, what will we do next?
Combine like terms.
Okay, then. Let's Jude. Can you continue instead until our final answer?
At the 8x cubed.
Cube,
8x
okay.
minus 2x squared minus 33x plus 27.
Plus 27. Yay, good job. So amazingly, we always can multiply any polynomial by a polynomial if we master distributive property. Okay? Um, Again, common mistake only that students do when doing this is the rule of exponents. Okay? When you forget about the rules of exponents, where we add the exponents if we are having the same basis or the same variable, and then we only combine like terms, that means the same variable with the same exponents, and then also following the rules of integers. Okay, so it's very obvious that you three master all these basic and prerequisite lessons, and therefore ready for special products. We will be dealing with difference of two squares, factoring, and yeah, more lessons, challenging lessons still about polynomials. Let us see for our next schedule. Okay? Any questions so far?
None, ma'am.
No.
None? Okay. I think that's all from me. Thank you, everyone.